So I'm Carroll, and I graduated from Virginia Tech in 1983 with a Bachelor of Science in Mechanical Engineering. And I didn't intend to work in the space industry when I got out of school. I actually wanted to work in the biomedical field. I've actually had a long journey back. I've actually been able to do some of that work at NASA, which has been a nice surprise. When I graduated from school, I took a job with Westinghouse, which is now Northrop Grumman, in Sunnyvale, California. So came all the way across country and worked in the defense industry, designing rocket launch systems for the Navy. And I worked in industry for about 10 years. And then I found NASA. And I've been at NASA ever since. I've been at NASA for over 25 years. And one of the reasons I love working in NASA and in space is because we never do the same thing twice. We are always developing and designing and building and operating something new. So if you think about the rovers that go to Mars, we start with the small ones, and then we move up to more capable, larger rovers that can do more. And we never build the same thing twice. And so from an engineering perspective, there's always a challenge. We're always creating new things and figuring out how to solve problems that others haven't solved. So while I've been at NASA, I've been able to work on everything from wind tunnels to arc jets, which is a hot wind tunnel. If you think about any kind of spacecraft that comes back to Earth, whether it's the space shuttle or one of these sample return missions that comes back to Earth or goes into any other planetary atmosphere, you have to protect the vehicle from that heat of reentry. And so I've had the privilege of working on thermal protection systems that are then tested in arc jets and enabling new missions. And in fact, some of the things that we invent at Ames then are transferred to industry. So for example, the heat shield material for SpaceX was invented at NASA Ames. And then we develop it, we make sure we know how it works, we understand how it performs and how to make it, and then we'd like to transfer it to industry to enable commercial space. So I've had a long history of systems engineering experience at NASA, leading to project management experience. And then I got into supervisory or just regular management of engineers and engineering systems and teams. And I'm now the Deputy Center Director at NASA Ames Research Center. They benefit life on Earth in so many ways. So I'll start with the technical ways. Everything from the inventions that NASA makes, whether it's temper foam, if you have a temper foam mattress for yourself or your puppies, that was invented at NASA. The cameras that are in your cell phone were invented for the space program by an inventor at JPL. So there's very tangible benefits of the space program to your everyday life. CAT scans and MRIs are based on technology that was developed for NASA. And so the inventions and the technology that we develop improve lives on Earth. On aeronautics, every time you get into an airplane and go somewhere, which hopefully we'll be doing again soon, we're there with you when you fly. Especially at Ames, we develop air traffic management tools so that we can get you there quicker. We can avoid storms and we can save fuel. And we're looking at green aviation, electric aircraft, so that we can not contribute to climate change as much. So those are very tangible benefits of NASA technology to your everyday life. And then there's the intangibles, right? I think one of the things that NASA provides is inspiration. I think we inspire the world. And we inspire the world to be better, to do better. We inspire the world to go further, to explore the unknown. And I think that's part of what it means to be human, is to wonder and to discover and to continue to uncover the mysteries of the universe. And I think that's a very human, belonging, important aspect of what we do. So I would encourage all women, all people, all backgrounds, to pursue a career in STEM. STEM is hard, and therefore it needs the very best in thinking, and it needs diverse ideas and different ways of looking at things. And so we really need women in the field. There sadly are not. It's not equal. There aren't as many women in STEM as there are in the world. And I'd like to see that change, because women bring a different perspective and a different approach to problem solving, which is really what engineering is all about, right? It's all about problem solving. And you have to bring diverse thoughts and diverse people together to think about things differently. And women really make a team more successful. So I encourage women to pursue a career in STEM and space. And my role models were, one of them was Joanne Morgan. And I didn't know it at the time that I met her, that she was one of, if not the only woman in the control room during the Apollo era. I did not know that when I met her. All I knew was that I was a pretty young engineer and she was in the room as an executive, as one of the only females in the room as the executive. And I just looked at her, how she behaved, how she sat at the table. She asked hard questions, and she just was such a great role model to me, as a young engineer. I really looked up to her. And now that I learned more about her career, I'm even more impressed. I can truly, honestly say Virginia Tech changed my life. I was a very awkward, unsure uh, high school student, and going to Virginia Tech, it was 8 hours from my home, so it was very far away. I didn't know a soul there. And I really came into my own in Virginia Tech. I grew up in Blacksburg. I became a more confident person. I figured out who I was and what I wanted, and I took charge of my life. And it really was a turning point for me in my life, that I realized that the only person in charge of my life is me, and that it's up to me to make the decisions that are best for my future, both personally and professionally. Um, Virginia Tech had a great engineering education. So when I first was an early design engineer, I was well prepared. And I was well prepared, not just with specific knowledge, but in how to approach a problem, how to approach problem solving, analytical skills, how to ask the right questions of the right people. Because when you come out of school, or even now, you don't know all the answers. You can't know all the answers. And so, how do you get the best team and the best group of people together to solve those problems? And I learned that at Virginia Tech. And then, as a fun fact, I love working at NASA and traveling to the different NASA centers and meeting fellow Hokies. We had a senior executive meeting at headquarters a few years ago, and we were amazed at how many Virginia Tech graduates are in the leadership ranks of NASA. And so I meet Virginia Tech graduates all the time, and you have an instant bond because Virginia Tech is such a unique and amazing place. Well, in keeping with the space theme, what I hope to witness in my lifetime is humans on Mars. That has been a dream of ours for decades. And one of the reasons I find that so inspiring is because the technology that needs to exist in order to safely take humans to Mars and bring them home is pretty amazing technology. If you think about the advancements that would have to be made in communications and medical work. I mentioned earlier that I was very interested in biomedical engineering. At the time I went to college, that wasn't a degree. You couldn't get a degree in biomedical engineering. But I'm happy to say that in my career, I've gotten to work on medical research on the International Space Station, where we're studying the effect of space on living systems. And we're understanding that when you go to space, you can, it changes the human body. It changes your immune response. It changes your bones. It changes your eyes. It changes your heart. And so imagine the things we'll have to know and understand in order to safely take humans to Mars and bring them home. I think that would be an amazing day for humanity. I would just say, pursue your dreams. You're getting a great foundation in education, personally and professionally. Excuse me. You are learning the skills needed to solve the world's most difficult problems, whether it's clean air, clean water, space exploration, energy. The world needs you. And I would encourage you to seize the day, take the hard job, always take the hard job. Always take the job that you don't think you're ready for. Always take the job that you're unsure about, because guess what? You will rise and you will meet the challenge and you will surprise yourself along the way. So seize the day.